so welcome to the 5th R tutorial that I've been making for you guys. This one specifically covers the chapter 12 and 13 project. Sorry I'm getting this to you guys a little late. It's been a rough week. So our project covers simulating dice rolls and set probabilities for free throws. So let me show you the code we're going to use for that. So let's use R to simulate rolling one 20-sided die. That's typically called a D20. And I want us to replicate this simulation 10 times, make a probability histogram, compute X bar, which is our mean, and S, which is our standard deviation for our sample data that we've made. Then I also want us to draw a normal curve on our histogram. I give you the code for that, right? Let me emphasize it though so we can see it better. I do give us the code for that. And then I want us to use, for that, I want us to use our sample mean and sample standard deviation to approximate. And then I want you to tell me X bar, the standard deviation, and print your plot. And tell me, does a normal curve approximate this data well? I'm already telling you, in this case it does not, but we'll see why. So the first thing I want to do is I'm going to create a sample. So sample, right? Sample takes a sample of the specified size from the elements of X using either with or without replacement. So replacement's typically false, but here we're going to set it as true because when you roll a dice, you can roll the same number more than once. So what you would do first for sample is you put your range of numbers separated with a colon. So here I did range from 1 to 20 because it's a dice, 1 to 20. I'm also going to do the number of time it repeats, which I can't type. So here we're going to repeat this test 10 times. And I want replace equal to be true because we can roll that same number multiple times. So here's my code. I'm calling this data set dice. That's a good name. So let's run that and see what it looks like. So here are the 10 dice rolls. I can then organize this as a frequency table or as and it did decide to bin that data, or as a probability table. My standard deviation is 7.3. My mean is 10.3. So if I want to put a curve, I give you the code, right? So I have to put this curve right under histogram and run it at the same time. So I'm going to make this a probability distribution. So if I run this code, here's my normal distribution on this graph. As we can see, this graph doesn't fit a normal distribution, okay? Well, I only rolled this dice 10 times. Of course that's not going to fit a normal distribution. Well, what if I complete this experiment 10,000 times? So let's let D1 be if I complete this sample 10,000 times, rolling a dice from 1 to 20, replacing it, right? I calculate its standard deviation, mean, and then I run this to see the curve. So it still doesn't fit our normal distribution, but it's kind of got like an outlier over here, like it's always rolling 1. Let's look at a table actually of dice 1. Table, dice 1. Oh, so I did get, 1, 2. Very interesting. They're all very close together. Maybe it combined 1 and 2, I think. Odd. Okay, so still not normal. It looks more like a uniform distribution, right? What if I did this 100,000 times? Let's try that again. Still, 1, 2. So it did combine 1 and 2. I don't know why it did that. So still not fitting a normal distribution. This looks like a really like a uniform distribution, okay? So what if I was looking at the sum of two 20-sided dice? This time what we should do is compute the sum of two dice. So I let dice 1 and dice 2, and then I can add them. I could name it dice sum because I'm adding them together. And if you want to see the top of dice sum, it looks like this. Next, we can calculate the standard deviation and mean, and I can put those in there. I could either type in the number or I could type in the function. So let's see what this looks like. Okay, so now it definitely does fit a normal distribution when we're looking at the sum. Yeah. So that's kind of the first problem. And again, I didn't do it here, but you could add colors. You could, you know, make it a pretty color. You could add a title, better X and Y labels. It's up to you. Okay, so now I want to talk about setting up samples with specific probability. So Dr. Miller is a terrible basketball player. This is true. She only makes 17% of free throws. Suppose she takes 10 free throws in a game, and we're going to let X be the random variable, which is the number of free throws she makes out of 10. So let's use R to simulate Dr. Miller's game and compute X. We're going to repeat this situation 10,000 times, make a histogram, compute our mean and standard deviation, draw a normal curve like we did before, and then really think, like, does this data fit a normal distribution? So there are two ways to solve this, one using the R code R binom and the other using the R code that's sample. So let's look at this like R binom code, right? Let me type that in, R binom, with a question mark in front of it because that's how I can learn more about it. So here's our binom. If you want to read about it, you can, but I'm going to go ahead and break it down. So there's D binom, which breaks down, which gives the probability density of a distribution at each point along our distribution. P-nom, that gives you the cumulative probability of an event. So if I want to know the probability of getting 26 or less heads, think about a normal distribution, right? 26 or less heads, I would run this code, and the probability is 0.5, 51 coins, 26, right? It's 61%. Now Q binom undoes P binom. So I want to know how many heads will have a probability of 0.25, will not 0.25, 1.610116 will come up when a coin is tossed 51 times, and the probability of getting heads is 1/2. So we get 26, right? It undoes. You know, if I wanted to know the probability of getting 2 heads, that's really tiny, but I could totally put it in. If we repeat this, and see it undoes the code. Well, it got pretty close. It was 2, now it says 3. Okay, so R binom, this function generates the required random number of values of a given probability from a given sample. So here I want to find 5 random samples from a sample of 100 with a probability of 0.5. So here would be 5 random samples from 100. So to answer the problem above, where I'm a terrible basketball player and only make 17% of free throws, what we want to do is we're going to do R binom, and it says I've got 10,000 attempts at simulating 10 free throws, that's my size, at a probability of 0.17. Right? So there it is. So here is it randomly generated 10,000 numbers. It skipped printing all of them, right? But here's 1,000 of them at least. So I could call that X, We can make a histogram of it. We can make a standard deviation of it. We can find the mean of it, right? And we could also add that curve, right? So let's go up here and grab our curve code, because like, why reinvent the wheel? So mean x, standard deviation x. I need this here. I need probability to be true. Let's run this. Please work. Why didn't it work? Unexpected parentheses. Okay, I didn't have enough parentheses. That's really common. What am I doing wrong? Add true. So this is what happens when our code doesn't work. Why isn't our code working? Would it have worked if I didn't do this? Would it work now? Unexpected symbol, mean, oh, see, I didn't put that parenthesis there. If you were just yelling at me through the YouTube channel to be like, Dr. Miller, I appreciate your help. Let's try that again. Oh, perfect. So it doesn't really feel like it fits a normal distribution. It looks kind of skewed, like skewed to the right because the hump's on the left. So that's one way you could make this code. Another way we could solve this is to use the sample code again, right? So sample, we give it a range of samples separated with a colon, size, whether or not to replace it, and then we could use a density binomial this time to calculate that. So here I have capital, let's call it x2, to be our sample. Let's take a look at that. So here's x2. So there it is. Notice it looks pretty similar to our long list above. We can make a histogram of x2. We could calculate the mean and the median. I'm giving it, I wouldn't name anything lowercase x. I don't know why I did that. That's bad math behavior. So here's our histogram. Again, it's left skewed. We've got our mean and our median. I could even add the curve if I wanted to. But this time I have to do x2. Let me run this. But it has to be on a probability distribution in order to work. Okay, that's a good note to add. Must be prob distribution in order to add a curve. Okay, so there is your 5 tutorial. As always, I have made a PDF document for you as well that I will load shortly.